Hello, this is the 8.1 notes, linear inequalities. I can graph a linear inequality and understand a linear inequality in context. There are three big picture steps. The first one is to graph the boundary line. The second is to determine whether that boundary line is solid or dotted. And the third step is to determine where the shading is, because for linear inequalities, essentially you're graphing a line, and you're shading on one side or the other to show which part is included. So, for the first example, y is less than or equal to 1/2 x minus 3. If the inequality itself throws you off, remember for the initial graphing piece, we're looking at it like a line. So the y-intercept will be right here, -3. The slope is 1/2. So since we have less than or equal, and this piece is up here, since it's less than or equal to, it's included. So that means it's solid because the boundary line itself is included. So if we graph this, we can start with plotting the y-intercept, -3. 1/2 is our rise over run, so we go up 1/2, up 1/2. We can even go the other way and go down 1/2, down 1/2 to continue that same line. It was solid, so we can connect that line here. Imperfect, but will work perfectly fine. Okay, there's our line, and now we need to determine whether it's the top or bottom of that line. To do that, let's pick a test point, one that isn't on the line. Let's go with 0, 0, because it's fairly easy. It's a good enough reason. So if we put 0, 0 into the equation, we'll end up with 0 is less than or equal to 1/2 times 0 minus 3. Is 0 less than or equal to -3? No, it's not. So that is false. So 0, 0 is not included, and since that's up there, we want the other side for our shading. For the second example, we have y is greater than -3x plus 5. Y-intercept is our 5. Our slope is -3, or -3/1. So we know that since it's y is greater than, there's no line underneath it, not including, so it'll be a dotted line. We can start with our y-intercept of 5. Down 3/1, down 3/1, down 3/1, and one more for good measure, down 3/1, and then we can connect that. We have our slightly wobbly line. Okay, except I didn't make it dotted. So let's fix that. That should actually be a dotted line. Now if we do our test point, 0, 0, if we do that, we end up with 0 is greater than -3 times 0 plus 5. Is 0 greater than 5? It's not, so that's false, so 0, 0 is not in there, so it's over here. And again, this is technically a dotted line, since it's not included. For our third example, y is less than -2/5 x. The y-intercept, 0, no, there's nothing there, it's a plus 0. The slope is -2/5. Since it's not included, it's a dotted line. So we can start at 0 and go down 2/5. Go back the other way, up 2/5. We'll make our dotted line. And now we'll do our test point. Normally I would go with 0, 0, but since 0, 0 is on the line, that won't tell us anything. So let's try 1, 1, another fairly basic numerical option. So we'll end up with 1 is less than -2/5 times 1. Is 1 less than -2/5? No, it's not, so it's false again. So 1, 1 is not in there, so it's this side down here. Okay, and at this point it seems like it's always going to be false. That's not the case, just a coincidence. Going down below, it's a similar idea, but now they aren't all in slope-intercept form. So our options are either solve it for y and put it in slope-intercept form, or you can graph it by plotting points. Typically x and y intercepts, but any points would work. And no matter what, we'll still use a test point to determine shading. So for the first example, let's do x and y intercepts for graphing. But first of all, Since it's greater than, it's not included, so it'll be dotted. So if we find the y-intercept when x is 0, if we plug in 3 times 0 minus 4y equals 12, I'm switching it to an equals for now because we're just plugging it in and for now treating it like it was as if it were a line. If we have that, 3 times 0 minus 4y is 12, we end up with negative 4y equals 12, so y equals negative 3. So the point that gives us is 0, negative 3. So we can plot that. Our other point is if we find the x-intercept by plugging in 0 for y, 3x minus 4 times 0 equals 12, which is 3x equals 12, so x equals 4. So our other point is 4, 0. So we have our y-intercept and our x-intercept, 0, negative 3, 4, 0. We can connect that with our dotted line. Okay, and now for our test point, we'll do 0, 0 again since it's not on the line. So 0, 0, and now is 3 times 0 minus 4 times 0 greater than 12. So is 0 greater than 12? It's not, so it's false. 0, 0 is not included, so we can shade below. For the next example, I think you could choose either way. You could do x and y intercepts again. I'm just going to solve it for y because it's simple enough to do. If we subtract x on both sides, we'll end up with y is less than or equal to negative x plus 5. So then our y-intercept is 5. We can plot that. Our slope is negative 1 over 1. So we can go down 1 over 1, down 1 over 1, as many or as few points as you want. Connect it. Since it's included, less than or equal to, it is solid. Connect the points, and there we go. Our test point, 0, 0 works again, not on the line. So is 0 plus 0 less than or equal to 5? Or is 0 less than or equal to 5? And it is. We finally have one that's true. So that means we will shade the side with 0, 0. Okay, our last example like this. Let's go back to x and y intercepts. First of all, dotted because it's not included. If we plug in 0 for x, we'll have 2 times 0 plus 5y equals 10. Again, we're using equals because right now we're literally just graphing the line and not worrying about the inequality yet. So if 5y equals 10, y equals 2. And our point that we have, our y-intercept, is 0, 2. If we plug in 0 for our y to find our x-intercept, we'll have 2x plus 5 times 0 equals 10, or 2x equals 10, so x equals 5. So our x-intercept will be 5, 0. So we have 0, 2 and 5, 0, and we connect that with our dotted line. And lastly, we do our test point, 0, 0, and keep in mind, if I haven't mentioned, you could use any test point you want, but 0, 0 is a lot easier to plug in than most numbers, such as you could do negative 2, negative 6 if you really wanted to, but that would take you more time. So we typically go 0, 0, or 1, 1. So let's see if 2 times 0 plus 5 times 0 is greater than 10. Is 0 greater than 10? Nope, definitely not. False. So we go above where 0, 0 isn't. Going to the next page, now we have real-world inequalities. So if you're selling tickets to a play, children cost $4 and adults cost $6. Your boss wants you to sell at least $60 worth of tickets. So if X is the number of children and Y is the number of adults, for the overall amount that you will make or amount of money you will make when you sell these tickets, $4 for each child times X children plus $6 for each adult times Y adults. We need at least $60, so $60 above, so greater than or equal to 60. So there's our inequality. As far as graphing, let's go with X and Y intercepts. Again, if you wanted to solve for Y, you could, but in this situation, I would choose the intercepts. So if we do 4 times 0 plus 6y equals 60, we end up with 6y equals 60, or y equals 10. So then we have our y-intercept of 0, 10. If we plug in 0 for our y, we have 4x plus 6 times 0 greater than or equal to 60. Or I'm sorry, equals 60, because we're just plugging in for now. So 4x equals 60, x equals 15, x-intercept of 15, 0. So let's plot those. We have 0, 10. We have 15, 0. Included, because it's at least $60, so $60 would be acceptable. So it's a solid line. And then for our test point, 0, 0. So is 0 plus 0 greater than or equal to 60? No. So 0, 0 is not included. Has to be on that side of the line. And again, what this means is that anywhere above this represents an amount of tickets you could sell for children and adults. So for example, if you go right here in that section, that would be the point 1510, meaning you would make enough money, at least $60 worth, if you sold 15 children's tickets and 10 adult tickets. The next example, your phone company charges you $30 a month plus $15 per 1 gigabyte of data use, and you can spend up to $900. So X is the number of months, and Y is the number of gigabytes of data, and we're writing an inequality. So in this case, it's $30 times however many months plus $15 times the number of gigabytes. And it's up to $900, so less than $900, because the way this is worded, we'll assume $900 is not included. As far as graphing, we'll do x and y intercepts again. So 30 times 0 plus 15y equals 900. So 15y equals 900. Y equals 60, leaving us with a y-intercept of 0, 60. If we find the x-intercept, 30x plus 15 times 0 equals 900. 30x equals 900, and x equals 30. So then we have 30, 0 for our x-intercept. At this point we can plug those in. So 0 looks like 60, that would be 65, so 60 is right below there. And 30, 0, so 25, 37 and a half would be here, so let's go 30, it's not exact, but that's okay. Not included, so it's dotted. Now we'll do our test point of 0, 0 as usual because it's the simplest. So is 0 plus 0 less than 900? It is. So we'll shade below. And again, what this means, really the information down in here doesn't mean a lot to us because it would be a negative number of months or data, but if we pick a point, say here, that would be at, well, that's still a negative. So really what we have here is down here, okay? So if we pick a point here, we would have maybe 5, 15. So 5 months, 15 gigabytes of data, that would work. So inequalities, and we'll talk about this more later in the chapter in different instances, but the railroad situations, you tend to not use the negatives. Okay, thanks guys. Have a great day.